So the querying in SQL is what it is useful for. And the basic query and the typical basic query structure is of this very, very famous select from where. This is a very, very famous construct of select from where. And what can you select? You can select a set of attributes, and you can select from a set of tables, and you can specify a set of, you can specify a predicate. Now, let us go over this one by one. These are attributes. These are relations. And this is a predicate. So what does this mean? This means that we want to select from the Cartesian product of R1, R2 to Rm. So we first do this R1 to Rm and only select those tuples where this P is valid, and we don't want to output all the attributes of them, we only want to output the attributes A1 to An. So that is the essential meaning of it. So if we write down the corresponding relational algebra query, so this is the following thing. The first one that is done is that R1, so all the cross product is taken. Then we apply the condition P on that, and then we select out only these particular attributes. So that is the equivalent relational algebra query. So now a couple of things is that, so the result of schema of all of this is essentially A1, An. So that is the schema it produces. So it produces a new table where the names of those attributes are A1 to An. Number one. Number two, if P is left out, P is by default true. So if P is, so you can, if you leave out where, then P is true. Essentially everything is selected. And you can of course select only one relation. And then there is a special syntax for select the attribute. You can say select star. Star means select all the attributes. So this stands for all the attributes. And P is 1 means it is true. Now, we have been saying that SQL is based on relational algebra, etc., etc. But what is the big difference of SQL from relational algebra is that SQL is a multi-set. SQL's relations are multi-sets. This is a very important thing. These are multi-sets. So what is a multi-set? It is just like a set, but an element can repeat. So it's a bags of tuples. So a particular tuple may show up more than one time in an SQL query, which is fine. In relational algebra, it is a set. It is strictly a set. So it does not let you select a tuple more than once. But in SQL, by default, it is a multi-set. So it can select multiple tuples. So a multi-set example, just to highlight the point again. So A, B is a multi-set because although the element A is the same thing, it is repeated, and this is not equivalent to AB. This is not the same as AB. But of course, this is equivalent to ABA because the set order doesn't matter. So that is a multi-set. So if, however, the SQL can behave like a relational algebra by specifying this keyword distinct. So if one says select distinct, this distinct essentially make it a set and not a multi-set. And the opposite of this distinct is all, which makes it multi-set. So all is by default. Fine. So we will go over each of these constructs select from where in some detail next. So we will use the same banking example as we have been using earlier. So a branch has a branch name, branch city, and an additional attribute called assets, which is the total amount of all the assets in the branch. The customer has a name and a city. The account has an account number, which branch it is in, and the corresponding balance. And the loan has a loan number, branch name, and amount. A depositor is a customer name and account number, and the borrower has a customer name and loan number. All right. So let us go over some examples. So first of all, suppose we want to select all branches where we want to select all branches from the city ABC. So how do we do that? So very simply, we want to select all branches So we want to select branch name from the table branch where the branch city is, you can simply say ABC. So this selects all the branches from the city ABC. Just to correct it, so this is branch city. And this is an equality operator which says within a string what is ABC. Now suppose we don't just want the branch name, we also want the assets, but we don't want the assets in terms of paisa or whatever, suppose, and we just want it in terms of some other arithmetical operation. So we can simply say that. We can say simply assets by 100 or whatever, it doesn't matter. Any arithmetic operation can be done on the select thing as well. So this is one way of doing the select, and the from is essentially from branch, etc., etc. And let us now go over to one or more examples on how to select something from two tables. So suppose if we do this, if we simply write this, select star from depositor, comma, account, then what happens? By the way, this is one interesting point to note, that the select and from are mandatory, but the where can be omitted. If the where is omitted, it essentially means where true, so that means all the tuples are selected. So if you just say select star from depositor account, this is essentially a Cartesian product of these two. So this is a Cartesian product of depositor and account. And essentially every tuple that is in depositor and account and all the values are selected. Now what happens is that depositor and account both have this attribute name a number. So how is it finally shown? How is it actually being represented is that, so the a number, what the point is that a number, this is a clash of the names and this is ambiguous. So if something needs to be done on one of the account numbers, that needs to be specified. So for example, if we want only the depositor account numbers, so what we may need to do is, instead of this, what we will need to do is, you say select depositor dot, so this is the dot operator, dot a number, and suppose we also want to select the whatever balance, etc. So depositor dot a number, that means now we are only selecting the a number from the depositor column. And by the way, this, if you just write this query, as you can see that this query, this is a Cartesian product query. This is not very useful. We would rather want the join that we saw earlier. So how do we specify the join? Again, the join is an equality join. So we have to simply say a number of account is equal to a number of depositor. So we can simply say a number is equal to a number. Now you can see that this doesn't make any sense. This is ambiguous. So what we need to say is we need to qualify this. Whenever there is an attribute that is repeated, we need to qualify it with from which table it is coming. So we need to say depositor.a number is equal to account.a number. And that is the way to do the selection of this. Fine. So that is the way things work. This is important. This essentially is a way of doing the join, and we'll see the example of join later. And now what also happens is that, so couple of more things is that this depositor.a number, this is a very clumsy name to use further. So the SQL lets one rename operator. So you can say instead of depositor.a number, you can add in depositor.a number as, let us say, AID. So finally what will be selected is AID and a balance table. So this is a table with AID and balance, because depositor.a number is renamed. So the as operator essentially is for renaming. This is the renaming operator as AID. And even depositor can be renamed. So we can write the above query in the following manner. Our relation is renamed. It can be used directly here. So again, you can of course have renamed depositor as D and just say D.a number and D.a number here and everywhere else. So that can be also done. So this is renaming. Renaming is not just a way to reduce the namespace clash or etc. It's not just a way of convenience. Sometimes it is necessary. And here is an example where it is necessary. Now this requires to find branches from branches with name DEF. This is a little complicated query, but this can be broken up into the following manner. So let me write down the answer to this query, and then it will be clearer as to how this can be done. So I am saying select, we want to find the names of all branches, so there is some B name that we require. From, of course there is a branch that we require. Now the where part. So what do we want? We want the branch, the B name of that branch whose assets is greater than the branch whose name is DEF. So what do? We require actually two branches here because we need branches from the branch relation twice. And now this is a problem. Now both are branches. So how do we do that? So we cannot use both as branches. So we must rename. So let us say we rename the first branch as T and the second branch as S. We want branch from T where T dot assets. This must be greater than S dot assets and S dot name, S dot branch name, sorry, is equal to DEF. So let us analyze this query first of all. So we are selecting the branch twice, here and here. One is renamed as T, one is renamed as S, and this is necessary. If without renaming it cannot work because both are branches. And we are saying that we want to select everything from this relation branch such that its assets is greater than S. But which kind of S? Only those S whose branch name is DEF. So essentially this to select the assets of the branch whose name is DEF, and we want everything else where that is greater and only selecting that. This is an example of a little complicated query and where renaming is necessary, and this also highlights the fact that the same name branch is used twice. That is why the renaming is necessary. Okay, just to, now that we are inside this branch name equal to, there are certain kinds of string operations that we can define. So we have been seeing this equality operator is equal to DEF. This means this matches exactly DEF. We can also say like DEF. So wherever this is like a percentage, so the percentage essentially is substring. So everywhere where the name DEF is there, it will be selected. And there are many such things. And so you can say a dot. So you can say like dot DEF. So dot stands for a particular character, and there is a regular expression thing that can be done here. So this can be checked up. So one important thing that we have been studying about relational algebra and SQL is that these are sets or multisets. So let us stick with SQL. These are multisets. So that means by default there is no ordering of the tuples. Now which is true, but sometimes the output needs to be in a particular order. Now once more, this is an important point to remember is that the SQL lets you run a query and lets you see the output of this. So now how to actually visualize the output? The output can be in any order that the database engine wants. But suppose you want the output to be in a particular order. So you can actually sort, but do remember the sorting is done after all the tuples have been selected, and this is just sorting is done only for the output of this. This has got no actual meaning in the model, in the relational algebra model or SQL model. So how do we do over the ordering? So you simply use, there is a construct called order by. So there is a construct order by which lets you order the tuples. So you can say select CNAME from customer order by CNAME, whatever. So the CNAME will be now in order, in ascending order by default. If you want to do something else, you can say descending. So by default this is ascending, you can also add descending to make it descending order. So this is one kind of operation. The other kind of operations is set, unions, etc. can be done, and you can also say distinct, etc. All of this can be done. So this is the set operation. The next important thing that we want to do is the aggregation. So the aggregation can be done. So again the aggregation is being done. So the aggregation. So 5 operations are allowed to be used. There are average, mean, max, sum, and count. So these are the 5 aggregation operations that can be done. And a query something like this can be specified. So select average balance from, let us say, so select average balance from account where, let us say, branch name is equal to DEF. So essentially it selects the average balance of all the accounts in the branch DEF. So this is a aggregation operation that is being done on the balance. Now as we saw earlier, it is not always useful to apply the aggregation on the complete set of tuples, but on certain groups of tuples. So how does the grouping done? The SQL offers a way of grouping the tuples, which is essentially using the construct group by. So there is a construct group by. This lets you group by. So again, we can do the following thing. So we can say account this thing, or also let us write down another query. So what are we doing here? This is important to understand, is that, so what are we trying to do here is the following, is that we are doing certain query, but we are saying group by a branch name. So whatever is the output up to this point from depositor account, etc. So we are essentially selecting all the accounts and all the on the depositor information around it. We are grouping by B name. So all of those tuples that are result as this are then grouped into different kinds of things according to how, whether they have the same branch name or not. Now once they have the same branch name, for each of these branch name, we are applying some aggregate operation, which is the count of C name. So the answer to this query is, looks like, is of the following form, is of the branch name and count of C name. So for each of the branch names, we will have the count of how many customers are there. That's the thing. So this is the same as the relational algebra that we talked about, the relational algebra grouping and aggregation that we talk about. Now one important thing is that the attributes in the select clause that are not aggregated. So this is the attribute in the select clause that are not aggregated. So this is not aggregated and this is aggregated. So this is not aggregated. They must appear, they must be grouped by. So they must appear in the group by, otherwise it has got no meaning. So for example, we cannot select branch name and, let us see, we cannot select branch name and branch city on the thing. So this branch city would have been wrong. This branch city would have been wrong because there is no way to get the branch city. Once you have selected by branch name, there is no way to get to the branch city. Or once you have selected, so it doesn't make any sense. So whatever is not aggregated in the select clause must be present in the group by. So this is mandatory. This is mandatory. Otherwise, if you just say select branch name, branch city, this thing, then it is wrong. So this is wrong. You cannot do this. This is one important thing to remember. Okay, fine. So then the group by, now you can say this is group by, but you can also qualify the groups. And how do you qualify the groups? You can qualify the groups. So you can say I want to select particular groups. So the qualifying is done by the having clause. So instead of saying select branch name and count C name from everything, etc., you can say, okay, I want to select the branches where the average balance or whatever, the average balance is at least some 1,000 rupees or something like that. So what you will do is, you will write down this same query, group by, etc., and in the end, you will add having average balance greater than whatever 10,000 rupees or something like that. So these 4 things, let me highlight these 4 things, these 5 things together is a query. So select branch name, count C name from depositor account where depositor.d name is equal to account.a number, group by branch name having average balance greater than 10,000. So you are not going to do the group by on every branch name, you are only going to do the group by on those branch names where the average balance is greater than 1,000. So this is like qualifying a group. This is qualifying a particular group. So this is useful because sometimes you want to analyze only certain groups which are useful to your analysis. So we will next consider the issue of null. In SQL, a value can be checked whether it is null or not by these following constructs: is null or is not null. An example query is of the following form: select L number from loan where amount is null. So that means it will try to find out the loans where the amount, there is some problem with the amount, it has not been updated correctly, etc. Now for null, again the same issue as the relational algebra happens. So this does follow that same three-valued logic. And evaluation, so result of expressions involving null evaluate to null, and comparison with null returns unknown, plus the aggregate functions ignore null. So for example, average, etc. will ignore null, but the only difference is the count star does not ignore null. Every other aggregate operation ignores null. So we will next move on to a very important part of SQL, which is called a nested subquery.